welcome to another NGen Math 8 lesson by eMathInstruction. My name is Kirk Weiler, and today we're going to be doing Unit 2, Lesson 1 on starting concepts in geometry. The next 3 units in Math 8 are on geometry, and further units have geometric thinking throughout them. So it's really important to kind of lay out the basics today, to review some things that you've already seen before, but also to really kind of lay the foundation of where we're going in geometry. And I want to be very clear about something. When I talk about geometry, a lot of people immediately think about, calculating the area of a rectangle, or the perimeter of a triangle or something like that. To me, that's what's known as geometric measurement. It's certainly part of geometry, and we're going to be doing a bit of it later on in the course. But this is a little bit different than that. This is really starting from the basic notions in geometry and building up our understanding of it through a variety of different methods. So let's get into it with a very, very simple question. Why do we study geometry? And this is actually quite important to me as a teacher and as a math student. I want to know why I'm studying what I'm studying. And I think it's pretty obvious when you study numbers why those might be kind of useful, right? And even algebra, you probably have a pretty good feeling for, and maybe even the geometric measurement. You might say, well, yeah, of course, I need to be able to understand what the perimeter of a room is, or the area of a wall, or something like that. So that all probably makes a lot of sense. But why do we study this more kind of basic notions of geometry? Well, I'd like to bring out a quote by somebody who studies geometry at Cambridge. All right, this is by Dr. Piers Bursell-Hall of the Cambridge Institute of Geometry, and I'd like to read this to you. Since the ancient Greeks, geometry has been a paradigm of truth and ordered knowledge, of clear thinking and the rigor of absolute precision of thought. But its real power is that it's also about the world around us. It seems that one of the most fundamental of human scientific intuitions is that the physical world is ultimately geometric, and that to study geometry is in some sense to uncover some kind of ultimate essence of the physical world around us, right? Our physical world is made up of locations, it's made up of points in space, and that's going to be where we start today and how we start to define things. So let's get into our study of geometry. Here we go. Now, geometry always starts with some very, very basic ideas. All right, so some real important starting concepts, let's go through these. Points and lines. A point is a physical location in space. It's got no length, no width, or depth. It has a 0 dimension. Isn't that kind of cool? It's 0 dimensional. And is typically drawn as a very small circle labeled with a capital letter. And this is very important because when you see points, as you'll see them all over the place as we do these lessons, really what you're looking at is a circle, not a point. You can't see a point. A point is literally, it's right there. It's this physical location in space. Now, a line, which is also a very basic idea in geometry, that's actually a little bit difficult to define. But a line is a set of connected points, right, one after another, that extends forever. And when I mean forever, right, in 2 opposite directions. A line is typically named using 2 or more points that lie on the line, or sometimes like a lowercase letter if we don't want to name points that are on the line. All right. Let's start with those 2 ideas and get into exercise 1. Let me bring this up to the top of the screen so that we can see it a little bit better. Make sure to have your rulers available or some kind of a straight edge. And let's get going. Exercise number 1. In the diagram below, 4 points are plotted. Do the following using a straight edge. Letter A, draw lines AB and CD. All right, first, before we even draw the lines, which is pretty easy, let's take a look at these 2 things, A, B, and C, D. Notice A and B are points. It's not like I'm multiplying variables together, and same are C and D. All right, and notice that what we have above those 2 points, whoops, sorry about that, is a symbol that kind of looks like this, right? That looks like a line. All right, and that's to distinguish it from various portions of a line that we'll get into in a little bit. All right, so let's now draw these lines. And again, it's very simple. If I want to draw a line AB, let me go in blue. If I want to draw a line AB, then I'm just going to bring my ruler over. I'm going to take my straight edge, right? The whole idea of a straight line. And I'm just going to draw my line in, right? I'm going to extend it past those 2 points, and then I'm going to put little arrows on the end of it. Great, right? Line AB, and I want to draw a line CD. Also pretty simple. It's going to be a lot easier for you. I've got to use this weird electronic ruler. But now we've got line CD. Bye-bye, ruler. Right? And again, those lines continue forever in opposite directions. Now, let's talk about letter B. Letter B has an important piece of terminology in it. When there are 3 points all lie on the same line, they are called collinear. Collinear. Name 3 points that are collinear and 3 points that are not collinear in the diagram. All right, let's talk about this just for a moment, because one thing that I failed to mention, but is probably pretty obvious, is that if you have 2 points in space, there is only one line that goes between them, right? So the idea of being collinear, well, any 2 points are collinear, right? We would never sort of ask that. But 3 points can either be sort of all on a line together, or you could have the 2 points that lie on the line and then a third point that doesn't lie on it. So we want to name 3 points that are collinear and 3 non-collinear points. Pause the video now and go ahead and do that. All right, let's do it. Well, 3 points that all fall on the same line are points A, D, and B. So those are collinear points. A, D, and B. And you could list those in any order you want. On the other hand, if I want to list 3 non-collinear points, I actually have a lot of choices. For instance, C, D, and B don't all fall on the same line. A, D, and C don't all fall on the same line. I think I'll do the B, the D, and the C. Those are pretty clearly not on the same line. All right, so B, D, and C. All right, now the final question here, and this is very important as we sort of like start geometry, is to understand things that we can measure and things that we can't measure. So let's take a look at letter C. Why can't we find the length or the measure of CD? All right, and I don't know why it says what. It really should be just why. But why can't we find the length of line CD? Pause the video right now and think about this for a moment. Well, hopefully you wrote something down like, because CD has an infinite length, or because CD goes on forever, right? Anything like that makes a lot of sense. We never talk about the lengths of lines, and if we do, we would just say they're infinitely long, right? So maybe I'll say this: because a line goes forever, it has an infinite length. All right. So we do not talk about the lengths of lines. Let's keep going on and look at some other concepts. Now, lines go on forever in 2 directions. But we can have portions of lines, and this is exceptionally important. So let's talk about 2 important portions of lines that we can have. The first is a ray. A ray is a portion of a line that has a starting point and then extends forever in just one direction. So lines have no starting points. They're just a collection of points that lie in a straight line forever in 2 directions. Right? It's hard to define a line. But a ray is a portion of a line that has a starting point and then continues forever in one direction. A lot of people will think about a ray as kind of a half of a line, but that's a little bit weird given that lines really don't have halves, given that they're infinite. Now, the most understandable of all portions of a line, I think, is a segment. A segment is a portion of a line that has both a starting point and an ending point. So let's take a look at exercise number 2. Given the points shown, draw each ray that is specified. All right, well, take a look just for a moment at this thing, right? Ray DC. Notice, right? Let me like really blow this up so that you can see it, right? This symbol is a ray symbol, okay? Notice that there isn't another arrow on this end. What that indicates is that ray DC is a ray that starts at D, goes through point C, and continues on forever. All right? So DC will look like the following. I have to start my ray there. It has to then pass through point C. All right. Let me bring my ruler back up. And that is ray DC. Now that's very different than ray CD. That would start at C, go through D, and extend forever in that direction. But this is ray DC. So that is always the starting point. This is another point that the ray passes through and then goes on forever. Letter B asks us to draw rays MN and MP. So what I'd like you to do right now is pause the video and draw those two rays quickly. All right, let's do it. My handy dandy straight edge, which also happens to be a ruler in this case. Here we go. MP starts at M, passes through P, goes forever. I'll draw the little arrow in just a moment, but this is kind of convenient. Ray MN starts at M, goes through N, and then we get these arrows. By the way, this geometric object might look familiar. We're going to be studying it in follow-up lessons. That is, of course, an angle. All right? But don't worry about angles for right now. We just have this ray. Let's keep going. All right. Now, it's important. Rays, lines, and segments all kind of look the same in terms of the way that they're named. Very often, rays, lines, and segments are all named with 2 points that lie on the ray, the line, or the segment, right? Now, for a segment, which is what we've got in letter A, all right, we've got the 2 points, R and S, but notice, again, let me just blow this up a little bit. For a segment, there are no little arrows. And again, it kind of makes sense. Oh, this is a portion of a straight line that goes from R to S or from S to R, but it doesn't continue past them. Versus a ray, again, let me blow this up, right? Same 2 points, R and S, but we start at R, we pass through S, and we go on forever. And then finally, line RS, blowing it up, right? Well, that's a line that passes through R and S, but then goes forever in 2 directions. So let's just read through exercise 3 and then have you do some drawing. Exercise 3. In each of the 3 diagrams below, 2 identical points are shown. Draw each of the following using a straight edge. All right, we'll pause the video now and go ahead and do this. Now, you gotta love geometry, right? It's a lot of drawing, a lot of concepts, not so many numbers yet. We'll eventually have them. But geometry is really about understanding physical space. And right now, we want to make sure that we understand the difference between a segment a ray and a line. Yours are probably a little bit better than mine. There they are. A segment, a ray, and a line. And again, it may be obvious, but if we had all 3 of these things lying on top of each other, this would be part of this, right? It's this section. And this would be part of this. It would be from here on out. Here on out. I can't do that. So it's important, right? Both segments and rays are sort of subsets of lines. They're parts of them. Okay. Let's go on to our last little piece. Now, a lot of confusion comes up in geometry in the way that we name things. And notice, right? We've now named in this lesson lines with two arrows above them, rays with kind of an arrow that goes in only one direction above it, and segments, two letters that have like just this little line segment drawn above them. Oftentimes, two geometric objects, and when I talk about a geometric object, make sure you understand what I mean. A geometric object is a collection of points in space. That's what it is, a collection of points in space. Whether that collection of points creates a ray, a line segment, a line itself, a circle, a square, it doesn't matter. A geometric object is a collection of points. Oh, those up there, right? And one of the really annoying things, super duper annoying things in geometry is that you can often name the exact same collection of points, the exact same geometric object, in two totally different ways. So I want to look at that in our final exercise of the day in exercise number 4. Let's take a look. Points E, F, and G are collinear, right? Meaning that they all fall on the same line in the diagram below. For each problem, state whether the two geometric objects named are the same or different. All right? So we've talked about how to name things. We've talked about how to draw things. What I'd like you to do is pause the video, and I want you to think about each one of these cases. They're each kind of a little bit different, okay? And then we'll talk about whether or not they are naming the same geometric object or a different one. Pause the video now. All right, well, I'm going to draw these things a little bit bigger just to make sure that you can see them without us needing to go to the board, right? So the first two things that we're talking about are segments, segment EF and segment FG. All right, now segments are kind of nice because they literally have a beginning point, an ending point, and then they're the collection of all points in between that lie on a line. So literally, segment EF is this collection of points, right? And segment FG is this collection of points. And those aren't the same collection of points. They simply aren't, right? If they were, then these two things would be the same geometric object. But these things aren't. So I'm going to say no. Okay. Now let's take a look at letter B. I'm going to erase these two. Okay, in letter B, we have two rays. One of them is ray EF, and one of them is ray EG. So let's take a look at what these two sets of points are. Ray EF is the set of points that starts at E, continues towards F, and goes forever. So literally, ray EF is all of those points. And again, I can't circle them all because it goes forever in that direction. Now, ray EG is the set of points that starts at E, passes through G, and keeps going on forever. But that's the same set of points, right? It's the same set of points. So this is yes. Are they the same or different? Maybe I should say different. And maybe here, the same. It's really not a yes, no. It's are they the same or different? All right, let's take a look at letter C. Now in letter C, we're talking about two lines, right? And we're talking about the line EG and the line FE. Well, again, just kind of getting rid of this. A line, right, is the collection of points that passes through, well, E and G, that's EG, right? And then goes forever in two directions. So literally line EG is this. Now line FE would be the collection of points that goes through F and E and then extends forever in two directions. That's the same set of points. All right, let's take a look at letter D, where we're back to two rays, right? Ray GE and ray FE. All right. Well, ray GE, again, is this collection of points that starts at G, passes through E, and goes on forever. So, ray GE is all of these points. Ray FE is the collection of all points that starts at F, passes through E, and goes on forever. So ray FE would be all of these points. Those are not the same geometric object, right? Because ray GE contains the segment GF, but ray FE does not. Now, is ray FE within GE? Absolutely. But they are certainly not the same set of points because FE lacks some points that GE has. So these are different. All right. And again, this is one of the things that can really confuse students. It especially becomes problematic by the time you get to high school and you're trying to keep track of different geometric things in a given problem, and maybe the problem is looking at it one way, but you're looking at it a different way. And it's important to understand the same set of points, the same geometric objects can be named in different ways. And you'll get a little bit of practice on that in the homework. All right, so this is great, right? It's our first lesson on geometry in Math 8, first amongst many. We looked at the idea of a point being a zero-dimensional place in space. Then we looked at this idea of a collection of points that extend in two opposite directions forever as being a line. We talked about little subsets of lines like segments and rays, right? And then we also looked at the different names or different ways that you can name geometric objects. Of course, we're going to be using a lot of this in future lessons because geometry, almost more than anything else, builds upon itself lesson by lesson, idea by idea. I'd like to thank you for joining me for another NGen Math 8 lesson by eMathInstruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.